So a few ways to go about doing this. First of all, I could rationalize this by multiplying by root x plus y over root x plus y. So I got root x plus y over x plus y, and it's the same thing, right? So, well, first of all, I mean, this is always going to be positive as written, because square root of something on the GMAT, they only refer to the positive root if it's the square root of something. Just 1 over that, and then plus x and y have to be positive anyway. So it couldn't be 3 because that's not necessarily positive. What if y is bigger than x? You know, and they're like big like integers. Then root y would be bigger than root x, and this would end up being negative. So number 3 could be negative. So it isn't, you know, 3's out. It could be greater than that, but it's not the case that it must be greater than 1 over root x plus root y, or root x plus y, because 1 over root x plus y again has to be positive. So 3 could be negative, so that's out. So the next one is to compare, you know, root x plus y to number 1. Okay, well, they're very similar because we have, this is root x plus y over 2x. Compare that to root x plus y over x plus y. Well, here's the thing. Okay, the numerator is the same. What about the denominator? We don't know about x and y. One could be greater than the other. So if it were x plus x over here, that would equal 2x, and they would be equal. But what if y is less than x? Then x plus y is less than 2x, making this number 1 greater than what they give us in the stem. Or y could be greater than x. So x plus y is bigger than 2x, so that makes it a smaller fraction than what we, you know, or that makes this a smaller fraction than what we have originally. So number 1 is out. Now with number 2, it's again very similar too, because the denominator is the same. Let's compare root x plus root y over root x plus y. Yeah, that's what we have here. Okay, well, the denominator is the same. What about the numerator? Well, here's the thing. Root x plus root y is always going to be bigger than root x plus y. If you want to use some numbers and see, that's good. Like, how does root 2 plus root 3 compare to root 2 plus 3? Yeah, this is like 1.4. This is 1.7. Root 5 is approximately 2.2. So, you know, this is bigger than that. So no matter what, the numerator is always going to be bigger than the denominator. So number 2 has to be bigger than what's given in the stem, the 1 over root x plus y. You can also, if you want to, like square these out, square root x plus root y, and see what that gives you. So root x plus root y squared is going to be x plus 2 root x y plus y, that over x plus y, compared to what we have in the stem. If I square that whole thing, actually this would be x plus y squared, but it doesn't really matter because I'm just comparing the numerators. The denominator's the same. If I square what they give me in the stem, then I'll get, you know, x plus y squared, same thing, same denominator, over just x plus y. Notice this compared to this, okay? It's both, they both have the x plus y, but this also has the 2 root xy in it. So that's again why root x plus root y is always bigger than x plus y, or root x plus y. So it's 2 only.